Welcome to Skype Academy. Today we will be talking about Skype for Business clients. My name is Thomas Binder. I'm a Senior Program Manager in the Customer Experience and Deployment team. So let's take a look what we will be covering today. First I want to talk about the session scope, and then we will talk about the sign-in process. We will talk about discovery, how a client finds the server it needs to sign in, the authentication, how it can prove that it is allowed to sign in, and the provisioning, the information that the client receives from the server or service once it has signed in. Then we will take a look at the flows, how signaling works, and finally we will conclude with some information on troubleshooting. Scope. The clients we will be talking about will be the Windows PC clients, so we will be talking about Link 2013 or with the new UI Skype for Business 2015. We will be talking about Skype for Business 2016. We will be talking about the new Mac client, that's Skype for Business for Mac. And then we will talk about the mobile clients, iOS, Android, and Windows Mobile. Please note that this training is recorded in October 2016. That means that if you watch this recording at a later time, it might be that there are some updates and not all of the information is still accurate. If you're watching at a later time, I would always recommend to go back to Skype Academy. That's www.skypeoperationsframework.com/academy to check if there are any newer recordings. Very important when we talk about scope is also what is out of scope. We will not talk about media flows. So I said we are going to talk about flows. That will be for the signaling. But for media, there's a dedicated session. We do have a link to that session at the end with the resources, but since it takes quite some time to cover that topic, we decided not to include it into this recording. Also, modern authentication, similar, pretty much a topic on its own. At some points in this presentation, I will point out when modern authentication will be used or when there's something special about authentication, but in general, if you want to learn about modern authentication, this is not the training that you need to watch. Mobile device management, mobile application management. Well, mobile clients are in scope, but these topics, again, a little bit too specific, a little bit too much to put all of that into this one session. So all of these topics will not be covered. But now let's talk about something that will be covered, the client sign-in process. And we will be starting about the discovery. The idea about the discovery is, well, I have my client. I type in my zip URI, my zip address, that's tbinder@contoso.com, and now I need to find a server or the service. I need to sign in again. The question is, how does the client find out where this service, or in case of Office 365, this service is located? So how can the client sign in? Well, if the client signed in before, then we remember this location. So we cache the service location of the server or service to sign in against. And you can, this example for the Windows client, specifically for the Windows Skype for Business 2016 client, you can find this file that has the cached information. So you would go to %local app data %/Microsoft/Office/16. That tells you it's Skype for Business 2016. Otherwise, it would be 15 for Skype for Business 2015 /link/zip address of the user /endpoint configuration.cache. And if you open this in a text editor, then you will see some gibberish information, but there is also information that you can actually read. So in this example, John L. at ucemia.com signed in, and you can see here the FQDN of the pool and the IP addresses and ports of the front-end servers in this pool. So in this case, the user obviously signed in internally because it's a .local FQDN, cached that information, and before the client will do anything else while trying to sign in, it will try to connect to this known server. But what happens if the client never signed in before? Well, then we need to start the discovery process. In the discovery process, we will query a number of well-known DNS entries and try to connect. First of all, we will do link discover. So there are two defined DNS entries, link discover internal dot, followed by the zip domain, and link discover dot zip domain. So if my zip URI is tbinder@contoso.com, that would be link discover internal.contoso.com and link discover.contoso.com that my client would be looking for. If it is successful, then it will connect to link discover and find out where to sign in against, and we will cover this in the following slides. However, if these FQDNs are not defined, then we will start something that's called the cloud-based discovery. In the cloud-based discovery, if we don't get a response to the DNS queries for link discover internal and link discover, after 4 seconds, cloud-based discovery will kick in. And it will attempt to find out if the zip domain is homed in Office 365. Because if it is, we don't need to look for these specific domain dependent FQDNs. We can just sign in directly against Office 365. And we will also see in one of the following slides how this will look like. It's important to understand that cloud-based discovery is not supported for all endpoints at the moment. So as of today, only the Windows clients for Link 2013, Skype for Business 2015, and Skype for Business 2016 understand the cloud-based discovery. And then finally, we have the legacy SRV records and A records. In the old days, this is how clients tried to find the server to sign in against. Usually we started with the SRV records _zip internal TLS dot _TCP dot zip domain and _zip dot _TLS dot zip domain. And if those were not successful as well, then we would fall back to the A records, zip internal.zip domain, zip.zip domain, and zip internal.zip domain. But let's go to the next slide and take a look what the Discovery Pro looks like. So we start in the upper left corner. You can see that you start your Skype for Business client, you type in your zip URI, and now it queries for link discover and link discover internal DNS records. Now, if it receives a response, well, it will not do the cloud-based discovery. It will continue to sign in, and then basically we are where we want to be. We found the server or the service and trying to sign in against. However, if we don't get a response within 4 seconds, we will start the cloud-based discovery. And for this, the client will connect to a well-known URL, and that's this very long https://odc.officeapps.live.com and so on, including the domain of the user. And this is basically a web service that tells the client if the domain is hosted in Office 365, and there are 3 possibilities. There could be the answer being global. That means we know that this user is hosted in Office 365 multi-tenant offering that Microsoft has. It is possible that the response would be partner.microsoftonline.cn. That would mean that the user is hosted in Office 365, but not in the global deployment, but in the specific Chinese deployment. And if there's another answer, if it's not global or not partner.microsoftonline.cn, then it will fall back to the legacy behavior that we just discussed on the last slide. So let's continue with the case that the response is global. Now we will go another time to odcofficeappslive.com with a little bit different URL, also including the address of the user. And depending on the response again, the client will have different behavior. If the response is the org ID, then we know this is an Office 365 domain, and now the Autodiscover process will continue against webdir.online.link.com. If the response does not have org ID, well, then we will again fall back to the legacy behavior. Very similar the case if the response is partners.microsoftonline.cn when we query odcofficeapps.live.com the first time. If it is partners.microsoftonline.cn, then we will go to webdir.online.partner.link.cn to sign in. On this slide, you can see the sign-in behavior of Skype for Business 2016, how it tries to query for DNS records. And this is just recorded with netmon. And if you want to try that yourself, just clear your DNS cache. And then I would recommend to type in a zip domain of a user where you know it doesn't exist, so that you can get sure that it will go through the whole flow of trying to discover all of the different DNS records. So we start with looking at frame number 14. That's the first one that is highlighted. And you can see here that the client tries to resolve link discover internal dot zip domain. Then in the next line, we can see the link discover. And continuing, we can see the A record zip.zip domain. We can see the SIV record for zip internal TLS. Then we can see the A record for zip internal. Then we can see the FQDN for zip, the SIV record for zip. And then we can see the A record for zip external. And then if you continue looking at the log, line 28, which is unfortunately not highlighted, but you can see here that the client tries to resolve odc.officeapps.live.com. So we can see here as well that it tries to resolve that FQDN. And then we can see at line 70 that it tries to connect to resolve the webdir.online.link.com in order to see if it can sign in against this Office 365 domain. Okay, so now we understand how the client finds the server that it tries to establish the connection to, but let's now take a closer look on what happens when it identified that server. So in this very specific scenario that we are going to look at, we are assuming that we are using a client that is internal to a network and the company is using Link Server 2015. So this is not a user signing in against Office 365. It is an internal client signing in against the server. The first step is that we resolve link discover internal.contoso.com to the IP address of the front-end web service. If we would have here an external user signing in against the server, then the link discover internal.contoso.com would obviously not resolve. It would be link discover.contoso.com and it would point to the reverse proxy. The reverse proxy then would proxy all this traffic to the front-end server, and from there the process would look very, very similar. If this would be a user signing in against Office 365, then the user would probably also not discover link discover internal.contoso.com, but link discover.contoso.com, and it would again point to a reverse proxy in Office 365. But the bottom line on step here is that we will either have the IP address now of a front-end server for internal users or of a proxy, and the proxy will forward all the traffic to the front-end server, either for Skype for Business Server or for Skype for Business Online. The client will then construct a URL and send a HTTP GET request. And you can see the URL here that, well, the GET request is get autodiscover /autodiscover service.svc/root ? Followed by the zip URI. So in this case, the zip URI of the user is bob@contoso.com. And now the client will receive two URLs in the response. That is the both in HTTPS, pool1.contoso.com /autodiscover /autodiscover service.svc root domain, and then the same with /user. And the client will use this response to make a request to the URL with the user to retrieve the specific user home pool information. So right now, we are just pointing the link discover to any of our servers. So if that's internal, you have an internal user and you're using the server, so you would point the link discover to one of your pools. In case you have a director deployed, you would point it to the director. The client would connect to this Autodiscover service and would find out, well, what is the home pool of the user. For external users, very similar concept. Client would connect to one of the reverse proxies and then would get an Autodiscover response that would tell the user which is the reverse proxy that is associated with the pool where the user is homed. The client will receive a 401 unauthorized response from the web ticket service location header, because at that point of time, the web ticket service doesn't know who the user is. The user didn't even try to authenticate yet, but at least we know where we need to go to. If Autodiscover would be used here, then the server names that would be returned would be webdir.online.link.com, respectively for Chinese tenants, webdir.online.partner.link.cn. Okay, what happens next? The client will submit a request to the web ticket service to retrieve the metadata exchange document. So basically, and that's called the MAX document. So basically, it will talk to the web ticket service and will ask, well, what kind of data do you want and how do you want this data to be formatted? The web ticket service returns this MAX so that the client knows how a request must look like. And now the client will submit a request for a security token to the web ticket service and will supply credentials. And we will see this in the following slides on what the different options are to request a security token and how we can authenticate. But at this point, the web client is returned. The web ticket is returned to the client, and the client will now make a request against this Autodiscover URL to retrieve the specific home pool information and provide the user and get the user web ticket. So now the Autodiscover service can obtain the URI of the user from the web ticket and can retrieve the information from the user database and send the user to the respective server, or if it's an external user, to the edge server that is assigned to the home pool of the user. And that is something that has changed from previous versions where we didn't use the link discover process or this kind of auto discover process. If you would still use the legacy behavior with SRV records, then all the SRV records would point to exactly one edge server pool in your environment, and all users would sign in with this one edge server pool, but not necessarily to the pool that is local to the front-end pool where the user is homed. So this is some of the optimization that will help you to keep the signaling traffic local. While we don't want to address media traffic in this session, just as a quick note, media traffic will always be done via the edge server that is assigned to the home pool of the user. So the media traffic will always stay local, irregardless what you use for signaling. But this, just to stress it again, is an optimization that will help to keep the signaling a little bit more local. So what we are seeing here is the Autodiscover response that the user will be getting when they try to sign in. And we have a few things highlighted here. So if you look at the text highlighted in red, you can see here that the user will be told what is the edge server that this user needs to sign in against. And this will, again, be always this edge server that is assigned to the home pool of the user. The green, highlighted in green, is the UCWA or UCWA information. We will cover that in more detail later on. And this is something that you would see only in Link Server 2013 or Skype for Business Server 2015, but not in older versions, because UCWA was introduced in Link Server 2013. One very useful tool, if you want to check if all these A records are in place, as they should be, is the Link Connectivity Analyzer. You will find in the resources slide at the end of the session a link to the Link Connectivity Analyzer, and it's a tool that you can download and where you can check if you can discover all the required records so that you can get sure that your user will be able to sign in. A few considerations regarding disaster recovery. The assumption here is that you have a server, because this applies only to server. If you're using Office 365, well, we will take care of disaster recovery for you. But let's say you have a server and you have multiple pools in different regions or different geographies. You want to really get sure that if you lose one of your data centers, that users still can sign in. So the recommendation would be that you always use Link Discover and that you use GeoDNS that is aware of server availability. So this GeoDNS would send users, when they try to resolve the DNS entry, always to a local pool. But more important than the pool is local is that the pool is still online. If Link Discover does not resolve, there is a high chance that users won't be able to sign in anymore. And that would be really a shame if you have still servers available and pools available, but users can just not find them. So recommendation is to use GeoDNS with server awareness. If you don't have GeoDNS, then you should make it part of your disaster recovery procedure to repoint the Link Discover A record to a different server. And you should always put a very low time to live for this A record so that when you make a change, that clients pick it up very quickly. SAV records and multiple edge arrays. So if you have multiple edge arrays or multiple edge pools, you could, in theory, have multiple SAV records with different priority and point them to different edge pools. And the idea would be that if you lose your primary edge pool, that clients would still be able to, well, they would fall back and use the next SAV record that points to a different edge pool, and this way they would be still able to sign in. Yes, this is something that we used to recommend in the past. However, today, not all of the clients support SAV records, especially the newer clients. So the mobility clients and the Mac client, the new Mac client, will not use this legacy behavior. So if you just use SAV records, they won't be able to sign in, and also they won't have any benefit of your failover using SAV. The second drawback with using SAV records is, as said before, all clients will sign in against the same edge pool. So in your global environment where you have your 3 data centers and 3 pools, if the SAV record with the highest priority points to one of the edge pools, all endpoints will sign in using that edge pool. And only if you lose that, then they will start signing in against another one. But again, all will sign in against this other one. So the very clear recommendation here is use Link Discover and use GeoDNS so that you can have automatic disaster recovery on that level, at least on the DNS level. And if you don't have GeoDNS, get sure that you include in your disaster recovery guidance that to repoint the A record to a different edge pool. Okay, and with that, we want to zoom in a little bit on the registration, on how that works, how we authenticate, and what happens there exactly. We already mentioned that when you sign in against the server or attempt to sign in, that you will get an 4.1 authorized. And this is expected. So it will look like an error message in the zip log. We will see that later on when we look at one of the zip logs. You will see a red message that doesn't look great, but actually this is what is expected. Because the first time we try to sign in, we don't know what the server expects us to provide this information. So the first time we sign in, we get this 4.01, but the server tells us also what authentication mechanism we can use. And in this case, we're looking on an internal client, and this internal client would get the information that it can use NTLM, that it can use Kerberos, and that it could use the TLS DSK. We will talk about all of these in a second in more detail. Depending on your scenario, you might actually see different protocols being offered. First of all, protocols can be disabled. So if for whatever reason a company decides not to do Kerberos, they could disable it and you would never see it being offered. Also, some protocols have dependencies, so Kerberos can be only internal in a network. So if a user tries to connect over an edge server, they would not see Kerberos being offered, because the edge server doesn't offer that, because it wouldn't work. Okay, the first one we want to look at is NTLM. It's the NT-LAN Manager Security Protocol, and it's basically a challenge response protocol. The nice thing about it is that it only requires protocol layer connectivity with AD, so we don't need a direct connection from the endpoint to the Active Directory. Remember, we have a lot of users, potentially, who connect from the external network over the edge server, so they are not connecting directly to a domain controller. They have no way to talking to this domain controller, so they need to have some kind of challenge response authentication protocol where they can authenticate via the Skype for Business server. So this is used for remote login with username and password. And one thing that you want to be careful about is looking at the NTLM versions. So obviously we want to have the latest, most secure version, NTLM version 2. But if for whatever reason in your environment NTLM version 2 is not enabled, or if you support only a different bitness, not like we want 128-bit, then you might have a mismatch and external users might not be able to sign in. So talk to your security team, get sure that they use NTLM v2, and if not, go do the appropriate take the appropriate measures to enable users to sign in. It's important that the expectation for Skype for Business, client and servers, is the same as what your environment allows. So let's talk about Kerberos. This is only for Skype for Business server. You wouldn't see that in the service, because in the service you will never connect directly to any active domain controllers. You will always be an external users. But the way it works is that it's a ticket authentication based method based on a trusted third party. This trusted third party is Active Directory, and the way it basically works is that the client, when you sign in on your PC, it goes to Active Directory, it gets a Kerberos ticket, and with that Kerberos ticket it can then later on authenticate it against other services like Skype for Business. And because we have these three components, Active Directory, the service that you are authenticating against, and the endpoint, it's named after the three-headed Kerberos creature. In general, it's the preferred authentication protocol for Active Directory, and again, the nice thing, it enables this single sign-on experience, because you get this Kerberos ticket once and then you use it with all the different services. However, it requires the direct connection with Active Directory. Also, it requires a loosely synced time. So if the time on your PC is more than 5 minutes different from the time on the server, then you won't be able to sign in. The server will assume that, that your ticket is not valid anymore. And you need to provision a Kerberos account in Skype for Business. So per default, this is not enabled. So you, as an administrator, when you set up the servers, you need to go in and enable Kerberos and set up this specific account. Then finally, we have the TLS DSK. That stands for Transport Layer Security Derived Session Key. And it's basically a certificate-based authentication. One thing that you might be careful about is when you talk about this kind of certificate-based authentication, because usually when you bring this up with any group of IT pros, they will immediately start thinking about, well, I need to have some public key infrastructure, I need to have a certification authority that creates these keys, I need to manage the keys. Some of them might even like the idea of using their own public key infrastructure, PKI, and their own CAs, and want to use these certificates. But that's not really what we're doing here. What we are doing here is that the Skype for Business server or service will create a certificate specifically for Skype for Business and will send that to the user. And then every time the user wants to sign in, the user can use that certificate to sign in again against Skype for Business. Only Skype for Business will trust this certificate, and there's no way to use your own PKI infrastructure. So it is something that exists within Skype for Business, and it was introduced to enable branch office scenarios. In Skype for Business Server, if you have these survivable branch appliances, SBAs, you don't necessarily have any AD controller on site, and that means if you lose connectivity to your data center, you still need users to sign in. So we needed some way to authenticate users where neither the user nor the server have access to Active Directory at a certain point of time. Because the Skype for Business server creates that certificate, it will trust the certificate, and the user can sign in against the server using it. The certificate can be valid from 8 hours up to 365 days. The default is 180 days. And before the certificate expires, the certificate will be used to get a new one. So what we talked so far are the basic authentication methods, but there's something more that we are using in Skype for Business regarding authentication, and it's called the web ticket. And well, it is exactly that. It is a web ticket used for the web services, and we are using all kinds of web services. We're using ABS, the address book service. We're using DLX, the distribution list expansion, ABS web query. We are using RGS, the response group service, and the certificate signing service. And every time we want to use one of these services, the user needs to authenticate. In order to make that easier, we use a web ticket. This web ticket also enables authentication with bridging web proxies. And the idea would be here that the web ticket is sent in a message body, but not in the transport layer. And what that means is an SSL connection is created to a web proxy. The web proxy, as web proxies do it, breaks this SSL connection, creates a new one. So it's not the same session anymore. But because this web ticket is inside the message body, it's the content of the message, it will flow over this bridge, and the users will be able to authenticate. This consolidates all the web service authentication under a single standard-based framework. So this is based on all these standards. Web service transfer, trust, security, allows us to do use SAML tokens, allows us for SOAP, and allows also the web service metadata exchange. So in order to obtain a web ticket, we can use NTLM Kerberos PIN. PIN, we use that on our phone devices, or a signed certificate to authenticate. And it is requested when we need it, and that's usually during sign-in, and then it is reused until by the client until the until the web ticket expires. So basically, we use NTLM Kerberos PIN TLS DSK to obtain a web ticket. Then we use, if we don't have the certificate for TLS DSK yet, then we use this web ticket to get this certificate, and then we use the web ticket to authenticate against other services. And in the next slides, we will take a look at a few of these scenarios. So in this example, a user is going to sign in. And exactly as we discussed it before, the user sends the zip register to the Skype for Business frontend server and gets back the 4.1 unauthorized. In this example, we highlighted that there's that it offers the authentication with certificate TLS DSK, and in the blue box at the bottom, you can see what this would look like in the actual log. But you can see here that it provides this STS URI, and that points to the third provisioning service. So basically at this point, the user tries to sign in, and the user is being told, well, you need to get a certificate, because the user doesn't have a certificate yet. You need to get a certificate, and this is where you get it. So here we can see that in the zip log, this is the register that the client sends, where the client just says, hey, I would like to register. And coming back, the client is being told, well, you can use NTLM you can use Kerberos, and you can use TLS DSK. And if you're going to use TLS DSK, this is the third provisioning service URL where you need to go. So we are not signed in yet, but we know now where we can find more information from the certification web service. And this is where we're going to connect to get the MEX document, the Meta Exchange document, so that we understand what the certificate web service is expecting from us. And at this time, we cannot get a certificate, because for the certificate, we need to have first a web ticket. So basically, we need to authenticate against the certificate web service so that we can prove we should get a certificate. And the only way we can do that is getting the web service. So we'll look here at this message. This is what the client posts. So it posts for this metadata exchange document. And then looking at the response, we can see here that we get this response with a lot of information on where to connect to and how to authenticate. And that's actually highlighted here. And I said in the beginning of the session that we will not talk about modern authentication. This is one of the few examples where I want to point out what is different in modern authentication. So in modern authentication, you would not see here this negotiate authentication. What you would see here is a pointer to the OAuth service, so that the client knows that, oh, now for this web ticket, we need to use modern authentication and we need to get this OAuth ticket. One other thing that I want to mention around modern authentication, we have seen previously that when the client tries to sign in, it gets offered these different authentication methods, NTLM, Kerberos, TLS, DSK. If you want to use modern authentication, you want to get sure that the client can sign in only using modern authentication and will not sign in using NTML or Kerberos. So you will disable these authentication methods on the server so that users can sign in only using TLS DSK. Okay, now the user connects to the Skype for Business web ticket service. And by the way, the web ticket service and the certificate web service, both of them are on the director or on the front-end server. And now it will request the web ticket MEX information for the security token, and will send the security token, and then the web ticket security token will be sent to the client. And we can use here NTLM, Kerberos, PIN, or what we can use actually in addition as well is the TLS DSK certificate if we got one from a previous sign-in. But well, actually in this example, since we want to get a certificate, probably we don't have one. But in general, when we go to the web ticket service, because maybe we need to query the address book, then we would also be able to authenticate with the TLS DSK certificate. So this is the request that we are sending. So we want to get here this information, and here you can see the security token that we are sending. And since this is negotiate, it's most likely NTLS or Kerberos authentication. And then we can see here the response from the server, and that includes the sample security token. That's actually our web ticket that we can now use. And that's exactly what we're going to do in the next step. With the ticket, we go to the Skype for Business certification web service. We have the request for getting a certificate. We will for getting our certificate signed. We authenticate with the web ticket. The certification web service can see, oh yes, you have a valid web ticket, so I'm going to create that certificate for you, and then it will send that information to the user. And now we have exactly established what we wanted to. The user knows now the private key for the certificate. The certificate is signed by the Skype for Business server, so the Skype for Business server knows to trust it. If you want on the server to understand what certificates have been issued, you can use the get CS client certificate commandlet to return a list of all the certificates that your server infrastructure has issued so far. And if you need to revoke any of the certificates, you can do that with the revoke CS client certificate commandlet. And this is also something you want to keep in mind. If, for example, a user leaves the company and you remove the user from AD or disable the user, they still have the certificate on their machines. And the Skype for Business server will still trust the certificate. So to get sure that the user doesn't use Skype for Business anymore, get sure that you revoke the certificate as well. So here we can see how that works with the web ticket. So the client sends the web ticket and gets back here the certificate. So we have done a lot. One thing we haven't done so far is actually signing in against the front-end server, the front-end pool. So now at this point, we will send a zip register with the certificate to the front-end server. Now we get the 200 OK, and now we are finally signed in. If the user has not a certificate yet, because the user has never signed in, it's the first sign in, you might see that during the first sign in, that the user will sign in actually using NTLM and Kerberos, given that they are enabled, so that we can speed up the process. So what you can see during the first sign in is that the user goes through the whole web ticket process, but at the same time in parallel already signs in using either NTLM or Kerberos, so that the user is signed in and then gets the web ticket and then has the web ticket to authenticate against all the other services. Also use the web ticket to get the certificate. So for the next sign in, can use the certificate and will be able to sign in with the certificate. And here we can see again how the user registers. So this is what the user sends for the registration. The TLS DSK is the authentication method of choice, and the server will return, yes, successful sign in 200 OK, and TLS DSK was the authentication method. So you should consider the signed certificate as the user password. It is really what the user will use to sign in into Skype for Business again. So if you sign in with your user into Skype for Business, and there's this check mark that asks you if you want to save your credentials, if you check this, it means that the certificate is stored as well on the machine, which is really great because the next time you sign in, the certificate is already there. What you want to be careful about is if this is a shared machine. If you are at the conference, you use your colleague's PC because you need to do a call, get sure to remove the check mark, because otherwise the certificate will be stored on the machine as well, and then your colleague could potentially sign in using that certificate. You can see this certificate in the certificate store. So if you open up an MMS and then add in for certificates and go into the personal store, then you can see this certificate. And that's what we can see here on the left screenshot, where we have the certificate manager in an MMS. In the personal certificate store, you can see this certificate. It's issued to, in this case, it's bstucker@microsoft.com, and it's issued by the communication server. You can also find it in the credential manager. You can see that on the right side. Again, same information, different credentials. If you want to clean up a user, well, if you know upfront that you don't want to leave your credentials, just don't click the Store Credentials button. But if for some reason you need to go back and clean it up, you need to remove it from both places. Perfect. We just managed to sign in a user. So let's see what happens next. Now the client provisioning will kick in. Client provisioning means that now that the client is authenticated against the server and has signaling established, it will learn from the server, or in case of Office 365 from the service, how it is configured, what it is supposed to do, what functionality it should offer to a user. If you use the snooper tool, and again, we'll look at the snooper tool at the end of the session, you can actually see all of this information as XML formatted text files, and you can see how the client is configured. And that can be very useful first for your own learning to just review the information that is passed down to the client, but also if you're trying to troubleshoot scenarios where you don't really understand why the client is behaving the way it is. So you can look at these logs and you can find out what the configuration is that the client actually gets. Here in the table, you can see the different parts of provisioning. So the function lists what function it is, so the location profile, and we'll take a look at this one in a second, but the location profile is the dial plan information for the user, how phone numbers are normalized. Then the user will get the contact list, the groups, the user will get the policies, the user will get self-presence, including information of what is my presence from other endpoints, but also information about phone numbers, all for this part of the presence document. Then user will publish presence if the presence changes on the one endpoint that you're on, the conferencing policy, and the media relay token. The debug string is what you want to be looking for in the log if you're looking for this information. And then finally, we have the type, either service or subscribe, which tells us if this is something that the endpoint pushes to the service, that's a service one, or if it's something that is pushed down, then it would be subscribe. So for example, contact list groups, it's subscribe. You subscribe to your own contact list. If on another endpoint you would update the contact list, all the other endpoints would be updated to have the same contact list. Now let's take a look at one of these provisioning parts, the location profile. Location profile, I said it before, also known as the dial plan, tells the endpoint what phone numbers should be formatted how. And you can see here quite some information. So again, XML formatted, so you can see here the name of the location profile. You can see different patterns, how they translate, if it's an internal extension, and so on. So again, this can be very useful if you see a certain client behavior, you're not sure if the client is really configured for that. Just look into the logs and find out yourself. So the next big section that we want to talk about is flows. And we want to talk about the signaling specifically. As said before, media flows are out of scope. And before we jump into the flows themselves, one little sidestep talking about the UCIVA-based clients. We have mentioned UCIVA before. Now more detail, it's the Unified Communications Web API, and it's a web-based API for the mobile client and Mac clients. And that allows us basically to send all our SIP traffic over HTTPS. And this way we can save mobile data, we can save battery life. It's a more efficient way to do all the signaling. And we will look in the next coming slides what that means to the signaling path. There's also the mobility service, the MCX. This is used as part of CIVA to do instant messaging, presence, contacts, all what we do with signaling on the mobile devices and Mac client. And there is this Autodiscover service that we talked in depth about already, how it works, and now we can see how it will help some of the clients to identify where they need to talk to. One note on UCIVA. This was introduced with CU1 update in Link Server 2013, so in the March 2013 update. And it's always our recommendation that you should run the latest updates of the server anyway. Just be aware that if you're setting up in a lab because you want to investigate some of the things and you don't have an update installed, well, then you won't see UCIVA on Link Server 2013. So in this first example, we just look on the Autodiscover, how it would work and what it means for signaling. On the very left, you can see the external DNS. Since we're here talking about the internal Autodiscover, we're not really interested in that. But then to the right, you can see the perimeter network having the reverse proxy and the Skype for Business Edge server. And then there's the internal network with our Skype for Business server pool. And on the pool, there is the web service. On the web service, there are actually two services running, the external with 4443 and the internal with 443. And all of them run the Autodiscover, the web ticket, and UCIVA. And we have here check using Skype for Business, and check will query the DNS for the internal DNS record link discover internal.zip domain. So this will point check to the internal Autodiscover service. And now check will do exactly what we have done, what we have seen before, but depending on the clients, the next steps are a little bit different. So if check is using Link 2013 or Skype for Business 2015 or Skype for Business 2016, then after doing the Autodiscover, learning what the home pool is, the client will connect via SIP directly to the home pool on port 5061 and will start with the provisioning and will be online. If the check is using a Skype for Business for Mac client, the client will connect via SIP over HTTPS to the internal UCIVA. And now, and that's very important, a mobile client, even if the mobile client is internal, the mobile client will always connect via SIP over HTTPS to the external UCIVA. So the flow, and we'll see that in the next diagram, from the internal mobile client will go to the internet and back in over the reverse proxy. And we decided to make this design on purpose because mobile clients, well, they are very mobile. So you might be in your office and then you go to the cafeteria and your wireless network might not be covered in the whole area. So on your way to the cafeteria, you lose the connection to the internal network. So now you would be over your cell phone data plan, you would be connected this way to the internet. And we want to get sure that the connection that you have to UCIVA is still valid. By using the external connection in the first place, we can continue using this external connection and don't need to re-establish the connection. So basically your client stays signed in the whole time. And while this is great functionality-wise, it requires a hairpin on the firewall. So the firewall needs to allow that connection from internal clients to the reverse proxy. So let's see how the signaling looks for Naya. She's using the mobile client. She contacts the internal DNS, learns about link discovery, goes to the Autodiscover. The Autodiscover then tells her that she needs to connect to the external UCIVA, and then she will connect over the reverse proxy to the internal UCIVA. So again, very important, this hairpin happening. For external users, very similar case. So now we have Amber here in the internet. She will query DNS for link discover. That will point her to the reverse proxy, and that will proxy all the traffic to the Autodiscover service. So what does it mean for external clients? For Link 2013, Skype for Business 2015, and Skype for Business 2016 clients, it means they will, after they have done the whole Autodiscover process, connect directly via SIP to the edge pool. And again, this will always be the edge pool assigned to the home pool of the user. So in an international, global deployment where you have multiple pools in different regions, the user homed in Europe will be pointed to the European edge server. The user homed in the US will be pointed to the edge server in the US. Skype for Business for Mac and mobile, well, these clients will connect via SIP over HTTPS via the reverse proxy to the external UCIVA service. And same here, it will be the reverse proxy local to their home pool. Media connectivity, I mentioned a couple of times, this is out of scope. We leverage very smart protocols. We have candidates and eyes and stun and turn. And if you want to learn more about that, I would recommend to watch the session on media connectivity. You can find it going to aka.ms/sa-eyes, and there is a 75-minute session that goes into all the details about media connectivity. Okay, now we managed to sign in a user, we understand the flows, but what if something doesn't work? Let's talk about troubleshooting. First of all, I want to talk about Snooper. And Snooper is the tool that we use to investigate all SIP traffic. It's included in the Skype for Business debugging tools. The link for that you will find in the resources slide. And it will help you to read the SIP logs. The SIP logs in theory are just text files, so you could read them using any text editor, but Snooper will really help you to understand what messages are part of the same SIP dialog. It will highlight message. It's really a very, very convenient way to read the logs. If you read the logs on the client, it will tell you all the traffic that is going on between the client and the server. Well, not exactly all the traffic. The content of instant messages will not be logged in the logging, but all the signaling around it will be, and all the metadata. This is a screenshot of Snooper. I mentioned before, if you see red in the tool, usually red is not a great thing, and here it means there was an error because the user was unauthorized, but this is exactly what we expect when a user signs in. The user just goes to the service, is not authorized, and learns more information.